Hello everyone, I wanted to make a quick video to go over making static maps, but I also wanted to quickly go over this Colab notebook just so that way you all could see kind of how I think through working through these Python notebooks and specifically give you some tips and tricks for coding in Python as you continue to go through much of the class. So the one thing I want to say here before we get started is that with Python, it really is a skill and you have to practice it. And so I'm being very generous by providing all of the code here for you, and you can play it, or you can run the code and see what the output is yourself. But you should really go through a lot of these different coding lines and review exactly what they're doing. So make a separate Colab notebook and just kind of play with the code and get an understanding of what it's doing and how it actually works. And the other thing I always recommend is, of course, reviewing the documentation for any function or package that you're not 100% sure what it does. And I know that sounds really tedious, but that's really the only way to really learn how this stuff works if you want an in depth understanding. If I were to do that for each and every single one of these packages, that in and of itself would take an entire semester. It's just too much time to spend to learn each of these individual packages. And so, really, I always recommend just learning by doing as you want to do something, searching how to do it. The other thing I want to address real quick is a lot of times nowadays, when you're hung up on something, people recommend using AI in order to find a solution. Well, back in my day, which honestly wasn't that long ago, I had to use what was known as Stack Overflow in order to find answers to questions that I had that I couldn't figure out myself. And so today we're pretty fortunate to have AI, I guess, in some ways, that we can kind of turn to in order to get answers to questions that we are unsure about. But AI is not perfect and it will give you broken code, especially if you don't know what you're trying to do. And so that's why I really, really emphasize that you need to learn the workflow, or what I call the programmer's mindset. So, exactly what packages you need, what data sets you need, what you need to do to the data in order to make it functional for what you are trying to do and analyze or map, and then ultimately what output you're looking for. And if you know those things, then you can essentially work through each of those individual steps to get a full working code to do what it is that you want to do. And so Colab makes it really nice in order to do that because we are provided with immediate access to Gemini down here if we click this little button. But Gemini does provide broken code. It won't always get things right, and that's because LLMs and AI don't understand context. So they don't know exactly what it is you're trying to do and why you're trying to do it. And so you either need to be really descriptive when you're asking it for help, or you need to work in steps and just go line by line through your Colab notebook in order to get things working. All right, so with that out of the way, I will go through this notebook and just provide some overview and explanation for what it is exactly that you're doing and how you can go about thinking about it as you go through this notebook yourself. So you should be familiar with a lot of the packages that we work with already: GeoPandas, Matplotlib, NumPy. These are all packages that are used for manipulating spatial data. So GeoPandas is essentially pandas, and these are both packages for manipulating data frames. Um, and a data frame is essentially a matrix of data. So these are columns and rows. And the best way I can illustrate that right now is to bring you to the spreadsheet of Python resources, which I've shared under the resources tab in the course. This is essentially a data frame. We have our column headers, name, so we know the name of something. We have description, which provides a description for the name, a link to the resource, tags, and other things that help provide descriptive elements to describe the resource. And so with a data set, you essentially have a similar setup for a data frame where it has a name of the data set, it will have values instead of a description. It'll have values associated perhaps with a time or a place over here. And we'll see that in just a little bit as well. GeoPandas is for manipulating spatial data frames, or otherwise called geodata frames. Matplotlib is for making plots or visualizations. NumPy is for numerical processing, and you can see that description here. Contextually is for adding base maps, essentially map tiles beneath the maps that we plot. Folium is essentially web map maker. It'll make interactive maps that you can kind of engage with. You can zoom out and you can change layers if you have different data layers plotted on the map. So I've already imported these and I've already installed all of these. So make sure you run these blocks on your end. Throughout, I've started embedding text descriptions of what exactly we're doing, what the key concepts are, and how they relate back to some of the readings that I have posted on the course for you to access. And so I do recommend taking the time just to kind of read through these to get an idea. For coordinate reference systems, again, these are kind of mathematical ways that we represent the Earth. So the Earth is not a perfect sphere, it is a geoid, and as such, we're going to have distortions in different parts of the planet when we are trying to map them visually. And because of that, that means that different data sets are going to use different coordinate reference systems in order to best illustrate the data that they are trying to show to the audience. The issue where it can become an issue is that if we are using multiple data sets, we need to make sure that all of these coordinate reference systems between the different data sets match up, which means we'll have to convert each individual data set to one coordinate reference system. Now, the master coordinate reference system, or the one that's most commonly used, is WGS84. That's the one that you'll see most commonly, and it is equivalent to another one that's called NAD83, which is North American Datum 83. They're pretty interchangeable, the two of those, and so if you're ever at a loss for which coordinate reference system to use, just use WGS84, which is EPSG 4326. In this workbook, we'll use some other coordinate reference systems, but you don't have to utilize those. And if you ever want to know what the other coordinate reference systems are, you can just Google them, coordinate reference system codes for Python. And so we should have a pretty good place where we can kind of find all these codes. So EPSG registry, proj system, and let's look for the EPSG registry. So you can find most of those codes here on this website. And so again, 4326 is the most commonly used. If you need a specific code, you can always look it up for the different projections which are available here. And I think I have touched on that in another document that I have shared with you all for this course. Okay, so the first thing that we always need if we're building that workflow mindset that I talked about, anytime we want to make a map, obviously the first thing we need is going to be some data. And so the data that we're most commonly going to work with for making a map is going to be spatial data. And so we'll almost always be working with a geodata frame. And if we have a data set that's not a geodata frame, we'll have to convert it to a geodata frame. So here we're going to make a geodata frame and of course assign it to our WGS84 CRS. And so with this code, we are making here a dictionary. So this is how you make a dictionary in Python. And our key value is going to be city. And then our associated elements to that key is going to be New York, London, and Tokyo. When you set them up in this order, you want everything to be in the same order. So we've established the city names. We want the latitudes to also relate to the same element numbers within this set, because within these brackets we have a set 0, 1, and 2. We want 0, 1, and 2 to be equivalent to the latitudinal value associated with New York, London, and Tokyo. So 40.71 is associated with New York, 51.50 is associated with London, and 35.67 is associated with Tokyo. And it's the same thing for the longitude. You want to do that as well. So don't put New York's 40 over here in element spot number 2, which belongs to Tokyo, because you're going to end up with some mismatched coordinates there. We then assign the data frame to a variable, which is just df, and now we're going to convert it to a geodata frame. So we're going to take df, and using GeoPandas, remember we called GPD. If we go back up here, we imported GeoPandas as GPD. So instead of having to type out GeoPandas every time we want to use a GeoPandas method, we can just type GPD and then the function from that package we want to use. So GPD dot, so we're calling the GeoDataFrame function, which belongs to the GeoPandas package now, and we're going to use it on the data frame that we made, and then we're calling the latitude and longitudinal coordinates that we have, and then assigning it the WGS 84 coordinate reference system. If I play this, as you can see, we now have a geodata frame where New York has our latitude and longitude, London and Tokyo also have them, and then we have geometry points. See these point attributes now in our data set. And these are latitude and longitudinal assets that are within our data frame. And with that, we can go ahead and make a map. So if I hit play here, oh man, that looks hideous. But we do see that everything is mapped accordingly based on our latitude and longitude. So London is where it's supposed to be. If we had a map beneath this of the world, all of our points would overlay on top of where they were supposed to be in the real world. So the next step is naturally going to be improving this. And so you don't have to do this every single time. That would be a huge pain if you always had to make a geodata frame of every location that you wanted to map out. It would take too long, and nobody would really be, interested in doing this because it would just be way too painful. So people have already gone ahead and made data sets with a whole lot of information loaded in. And so the natural Earth data set is always a good one to use. One of the easiest things you can do here, so a lot of folks have had some issues with file paths. For this particular file path, I'm linking directly to a website. So if you are confused about this, what you can do, instead of copying this end part, which is the file name, just come over here, copy this half of the URL, paste it into your browser address bar. Oh, it gave me a file. Maybe I copied too much. Come back over here. And it should take us to a website. Typically, and I don't know if the website is down, this might be just the file download link. But typically you can copy and paste this link and it will take you to a website where you can see where that data is hosted. Analysis. Oh, I think I see the issue. I think it's links code. That's not it. Oh, oops, put those. Natural Earth. Here we go. So this is the website that we are essentially downloading this data from. And it's just NASA's. So with our link in Google Colab, we have dn.org, which is the download path. But here we're just using the URL nassas.org initiative/natural earth, which takes us to the user interface website. So this is a real website that we can go to in order to look at this data. So when I press play here, I am downloading the data directly instead of downloading it to my computer. I'm assigning it to a variable and reading it in as a geodata frame. And now I can visualize or see this data frame because I used world.head, and I assigned the data set to the variable world. And when I use the head function, I'm essentially just asking it to show me the first 5 rows within the data set and tell me all of the columns that are in the data set. Now, the column names a lot of times are pretty ambiguous or obscure, and it's pretty difficult to determine what exactly they mean. And so that's where you would have to hunt down the website, which I've closed, in order to figure out what they mean. So some of them are pretty descriptive. You know, name is probably going to be the name of the area or the country. And so here we see admin has some country names under it. Sovereignty has the names of some countries under it, but name probably has the names of the countries under it. And then some other data points in here like population estimate, population rank. We can also see that as well. I've also included some code here to show you how to download the data if you wanted to open it in Google Sheets or Excel. So if you press play here, you can see that we saved it inside of Colab to the TMP temp folder. So if I click this, and right here where we have these 2 dots, I can click this to expand, and we can see the rest of the file system. I could scroll down to TMP and then scroll down to TMP, and there it is, world countries data.csv, and I can download this file onto my computer, which you can see right there, world countries data. And so if you want, you can import that into Google Sheets or Excel in order to get a better visualization of what exactly that data looks like and what each of those variables represent within the data set. So now let's go ahead and create a map. And here's our basic world map with all of the countries included inside of it. And so we took that geodata set that we downloaded, and we have plotted all of its information onto this map. And so all of the boundaries of these different countries are automatic or are already done. The work is done for us and it's recorded in here, and all we've done is simply visualized it. So it saved us a lot of time from having to go in and make all of these boundary lines by hand, by ourselves, coding them out. And of course having errors if we did that ourselves. And we have access to a world countries map simply by downloading that data set. The rest of this notebook just goes through some different ways to map out different things. So this part this section is mapping out world GDP per capita, but there's an issue with this map that I want you all to debug. And there's a couple of other maps that we will go through in this code as well that I want you all to debug also. So I hope you found that pretty helpful in terms of explaining exactly how to work through this and how to handle the data, and then of course how to make a static map. And remember, practice makes perfect. If you really want to get an understanding of Python and how you can utilize Python in order to make maps and analyze data, you really have to practice. So don't just come through here and click play and think that you will be able to go to a blank notebook and do all of this from scratch. You really have to understand, okay, why is he doing this line right here? Fig, x, plot.subplots. I'm setting the size or the dimension of the plot when I run this line of code right here. And then I put comments in here to basically describe everything else that I'm doing. So plotting all the countries. I'm using the dataset world to plot all the countries in a color that is light blue. I can change this if I wanted to. I can make it red, and then plot, and now all the countries are red, although that looks horrendous. So I'm going to go back to light blue. Edge color is the boundary line color, so I made it black, but we can make it white. And you can see now it's light blue with white boundary lines for the countries. Line width is 0.5. I can expand this and make it 2.5. And now we've got really big border lines, which also doesn't look that great. So I'm going to go back to 0.5. But you have to remember, this isn't definitive. Map making is both a science and an art, so it's really up to you to figure out what looks good and what will look good to your audience, because everything is audience dependent. Right now, that might not click so much because everything you're doing is in an attempt to please me, your instructor, which is good. But once you start working with this material in the real world, you're going to have a manager or a board member or stakeholders that you have to please with your maps. All right, I hope you found this helpful. And if you have questions, remember you can send me an email.